So we're really, really excited today that with Tegra, we've bridged the gap. We've brought mobile computing to the same level as desktop computing. We've brought mobile computing to the same level as supercomputing. We've brought the heart of GeForce and the soul of Tesla to the Tegra family. We've brought the heart of GeForce and the soul of Tesla to mobile computing. And we're really excited about that. Now, what's the benefit? What's the benefit of that? Well, the first benefit is solving, in fact, a very significant problem for game developers. If you take a look at game development today, just as you saw with Batman, the production value is incredible. It's completely cinematic. It's cinematic and also interactive at the same time. The computer graphics is cinematic. The experience is cinematic. The story has to be sufficiently broad and large and large in scope that you can actually enjoy the video game for 8 hours at a time, 10 hours at a time, 20 hours at a time. So there's enormous depth to the video games. And it stands to reason, with so much artistic contribution and so much technical contribution, that the production value, the production cost would be so high. In fact, most AAA titles today cost more than $100 million. Now, there's only one thing that you can do to solve that problem. You could either reduce the production value, or you have to have a larger footprint. You have to find a way, as a game developer, to reach more users. Well, in order to reach more users, unfortunately, the architectures are radically different. When you take a look at each one of the game platforms, the architectures historically were very different. They're becoming more and more similar. However, the architecture of mobile devices, which is the largest computing platform in the world today, and the architecture of next-generation game consoles are radically different. One of them is based on OpenGL ES 3.0, and the other one is based on OpenGL 4.3. The capabilities are radically different. The capabilities, the features. And so, for a game developer, the diversity of the platforms creates another degree of complexity that is simply intolerable. The developer's dilemma. They want to build great games, they want to take the financial risk, but they need to have large enough footprint that can accept and help people enjoy the creation that they make. And so today, we're incredibly excited to announce that Epic Games is going to bring their next generation engine, the Unreal Engine 4, to the Tegra K1. And Tim is a man of few words, for all of you guys who know Tim. And he has the highest expectations. We've been working with Tim now for 20 years. He has the highest expectations of anybody in the game industry. And he sets us so cleanly. He says we can take absolutely anything that runs on PC or high-end console and run it on Tegra now. I didn't think that we'd be at this level on mobile for another 3 to 4 years. Now let's take a look at what he meant by that. So if you look at this is Unreal Engine 3. This is the last generation game console. In the year 2002, we launched MV30, which was GeForce Effects, with the invention of DX9. DX9 brought to the world programmable shading. And the effect that we saw in video games were per pixel lighting. So video games became bumpy and shiny. Okay, whereas before it looked chalky and flat, now it looks bumpy and shiny. It came to life. And modern video games are still based on DX9. It wasn't for several years later that Xbox 360 and PlayStation 3 brought DX9 to game consoles. And then many years after that, it came to mobile devices. For the very first time, with Unreal Engine 3, with Infinity Blade from Epic running on an iPad. iPad was the first capable machine to be able to run an engine that was introduced in the year 2002. A span of 8 years' time. A span of 8 years' time that it took for the Unreal 3 engine that runs on Xbox 360 and the PlayStation 3 to finally be able to run on a mobile device. Well, that entire 8 years is what we consider last generation. It was the DX9 era. The DX9 era. If you take a look at most video games today, with the exception of some of the more modern video games that we're showing you, when you take a look at a mobile device or you look at a video game today, it's mostly DX9. That's the look of DX9. Well, here is the beginning of next generation. Next generation started with DX 11.1. I'll show you what DX 11.1 can do in just a second. We introduced it with Kepler. 1 year later, because of this incredible imperative to unify the platforms for the video game industry, the new game consoles are effectively PCs. It's architecturally identical to a PC. It's because of this incredible imperative to keep the platforms the same. 1 year later, the game console industry brought the same architecture to game consoles. As a result, now the game developers have a reasonable footprint to target with next generation DX11 games running Unreal Engine 4. But here's the really exciting thing for Tim. And what he said earlier is this. This time around, because of what we've done with Tegra K1, we have now reduced the amount of time that it's taken for next generation platforms to be able to reach not just PCs, not just consoles, but also mobile devices of all kinds. The benefits to game developers is really immense. Literally one singular architecture, one singular platform, and more importantly, one engine. Now the Unreal Engine, many of you guys have known, have been tracking the video game industry, is the most successful game engine of all time. Unreal Engine is effectively the operating system of games. The game AI, the game physics, the game rendering engine, it basically embodies the runtime of modern video games. Unreal Engine 3 had hundreds of games that were credited to it. And here comes Unreal Engine 4, the next generation. So that's what Tim is really excited about.